Okay, hello Math Counts friends. In today's video we're going to go over the 2026 school sprint and target rounds, and I'm just going to cover the problems that more than half of the people who took the test from my school got wrong. So we're going to go over the harder problems. Alright, so let's jump right into it. So the first one that more than half the people got wrong was this one. And I definitely feel like I bear some responsibility for that because I never talked about stem and leaf plots in any of our practices. So many of you may not have known what a stem and leaf plot is. But some of you may have looked at this key here and been able to figure it out. But let me just tell you what a stem and leaf plot is so that you'll know for next time. So a stem and leaf plot is just a way to record two-digit numbers if you have a lot of data, or one-digit numbers. And in this case, they're keeping track of how many points a basketball player has scored in all their games. So this number here represents a 4. It's a 0, 4, which is just 4. And this one represents 6, 0, 6, 0, 8, 0, 9. So these are, if you were to write all these numbers out, it would be 4, 6, 8, 9, and then 10. So this 0 here represents a 10, and then two 12s, 12, 12, and so on. So that this key is kind of pointing out that a 17 gets entered into the stem and leaf plot in the tens row as a 7. So this 7 here would be a 17. So basically, if you want to find the median, you have to find the one that's in the middle. Unfortunately, these are already sorted, so you can start just canceling out from the left and the right side, from the high and the low end. So for example, if you cancel out these 4 here, you can cancel out these 4 as well. And then if you cancel out these next 4, you can cancel out these. So you're kind of moving your way toward the middle, right, by canceling out this element. Now there's 5 left. The median is going to be the one in the middle, so this 8 here. And that 8 represents 18 points because it's in the tens row. So the answer here is 18. Alright, hopefully that made sense. Whenever you're looking for the median, you just look for the one in the middle. Fortunately, there was an odd number of entries here. If there's an even number, the median is it's the average of the two middle ones. Alright, let's go on to the next one. This is 16, problem 16. It says Sam is going to perform a juggling act for Crichton Middle School's talent show. The performance will involve juggling 3 balls, each a different color. Sam must choose from red, blue, green, orange, purple, and brown balls. How many different sets of 3 balls can Sam choose? Okay, so the important thing is it says that he's going to choose 3 balls, each of a different color. So you have to choose 3 of these 6 colors, and then Sam will juggle those balls. So the question is really, how many different ways are there to choose 3 items from a pool of 6 items? And in combinatorics, we call that 3 choose 6. You can write it like this, or another way to write it is to write it like this: 3 choose 6. And the formula for this, sometimes you might see it called n choose k. And the formula for this is you do the k factorial on the top, so that's 6 factorial on the top, and then in the numerator I should say, and then in the denominator you have 3 factorial, which is the n factorial, and then you also have k minus n factorial, 6 minus 3. Let me write that out like this: 6 minus 3 factorial. And if you write 6 factorial divided by 3 factorial, that's going to be 6 times 5 times 4, and I'm not going to write the times 3 times 2 times 1, not just because I'm running out of space, but because that's going to cancel out with this 3 factorial here. And then you divide this all by this is also 3 factorial, so that'll be 3 times 2 times 1, which is 6, and that can cancel out with this 6, and you're left with 5 times 4, which is 20. So 3 choose 6, 6 factorial divided by 3 factorial, that's going to give you 20 different sets. 20 different sets. Okay, now that's called combinations when you have a group of things and you have to choose a subgroup. If they said he's going to line up 3 balls in a row, a first ball, a second ball, and a third ball, how many ways can he do that? Then the order matters. And in that case, it's just 6 factorial divided by 3 factorial. Because there's 6 different colors that he could choose for the first one. Once he chooses that one, there's only 5 colors left for the second one. And then once he chooses that one, there's 4 different ones left for this spot. So that's what we call a permutation. But in this case, the order doesn't matter, so it's a combination. You have to divide by another 3 factorial, which is just another way of saying that basically, once you do this, well, if you were to do the permutation, you get 6 times 5 times 4 different ways, but there would be 6 different ways to order those balls, and they would all be counted. So you have to divide by that number of ways that you can order them, because you're basically counting those combinations each 6 times. All right, long explanation there, but hopefully that helped some of you who aren't as familiar with permutations and combinations. All right, number 20 was the next one that more than half of you missed. And it says, how many arithmetic sequences with exclusively integer terms have a first term of 20? Okay, so the first term is 20, and a last term of 26. Okay, so the most important thing here is to know what an arithmetic sequence is. An arithmetic sequence is basically a sequence of numbers where every time you go from one number to the next, you're adding some constant. We'll just call it C. And then when you go to the next one, you're adding that exact same constant C. And when you go to the next one, you add the exact same constant C. And so in total, as you go from the first term to the last term, you're going to be adding a total of 6. So basically it's saying how many different ways can you jump by the same amount to go from 20 to 26. In total you're going to add 6. One way to do it is to do it all in one jump, right? So we could write down the increment here, and it has to be an integer increment because we know that the terms all have to be integers. So the increment could be 6. Another way you could do it is to do it in 2 jumps. You could do 3 and 3. So that would give you an increment of 3. And another way to do it is to do it in 3 jumps, right? You could do 2, 2, and 2. So that would be adding 2 each time. And then the last way to do it is to just add 1 each time, right? So you do it in 6 jumps. So these are the 4 different ways that you can get from 20 to 26 with integer jumps all the same. So that means there's a total of 4 different sequences like that. All right, let's go to the next one. This is number 21. It says, what is the sum of all positive 4-digit integers A, B, C, D? So here A, B, C, and D are the digits of the 4-digit integer, such that the 2-digit numbers AB, BC, and CD are each perfect squares. Okay, so first we need to write down all the sequences that are 2 digits that are perfect squares. I suppose you could have a 1-digit perfect square, but then you'd have a 0 at the beginning, and it says that these are 2-digit numbers. So if you had a 0 there at the beginning, that wouldn't be a 2-digit number. So we want all the 2-digit perfect squares. So the first one is 4 squared. 4 squared gives you 16. Then you have 5 squared, which gives you 25. Then you have 6 squared, which gives you 36. And then you have 7 squared, which gives you 49. And then 8 squared will give you 64. 9 squared will give you 81. And once you go to 10 squared, you're doing a 3-digit integer. So these are all the 2-digit numbers that are perfect squares. And so we know that AB, the first 2 digits of this 4-digit integer, is one of these. So we can just go through each one and think about whether it could be AB. So if I started with 1, 6, then BC would have to start with a 6. So that would be this one here. So then the next digit would be a 4. And then the 4 is C, so the next one has to start with a 4, and that would give you a 9. So this, if you start with 1, 6, you're going to end up with 1, 6, 4, 9. You can do the same thing for 2, 5, but what you'll find is that if you put 2, 5 at the beginning, there's no possibility for C, because none of these perfect squares start with a 5. So that one you can kind of cancel out. And then you can go to 3, 6, and you can follow that same pattern. After the 6, you're going to have a 4, and again after the 4, you'll have to have a 9. And then for 4, 9, you're stuck because none of these start with a 9, so that one you can cancel out. You could do 6, 4, and then 4 would be a 9, and then 9, yep, we're stuck again. As soon as we get to a 9 or a 5, we're stuck. And then 8, 1, 8, 1, that means you're going to have a 6 next, and then you're going to have a 4 next. So we've got all the possibilities. We've got this one here, we've got this one here, and we've got this one here. And I'm not going to bore you guys by adding those 3 numbers, and you don't have a calculator, so you will have to do it by hand. But once you do that addition, you'll get 1, 3, 4, 6, 2. So that's our answer on this one. 1, 3, 4, 6, 2. Whoops. There we go. All right, let's go to the next one here. All right, so this one says a rectangle has integer side lengths, okay, with the shorter side at most 7 units and the longer side is at most 10 units. If the rectangle's area is at least 50 square units, what is the sum of the perimeters in units of all possible qualifying rectangles? Okay, so the biggest rectangle that you can have is 70. The area is going to be 70 because the biggest, the shorter side can be a 7, and the biggest, the longer side can be is 10. So we can imagine that, like making a table of different longer side lengths. So this is the longer side length, and then different shorter side lengths. Maybe in this direction. This is the short, I'm going to write it like this, shorter, longer. Yeah, let's just do that. And then this is 7, this is 10, right? So multiplying those two together, you get 70. And then if you start shrinking the shorter side length to 6, you get 60, and 5, you get 50. And you can see I'm basically just building a multiplication table here that goes up to 70. But I don't need to go below 50 because I know that the area is at least 50 square units. So then maybe I'll just build the table, I'll go back and build the table from 9, right? So 7 times 9 is 63, 6 times 9 is 54, and if I go below that, I'm not going to, I'm not going to be above 50. 5 times 9 is 45. So then I can go to 8, right? So 8 times 7 is 56, and that's all I need because 6 times 8 is 48, which is too small. And then I can go to 7 times 7, that's 49, that's too small as well. So these are all the different rectangles, the areas at least, that satisfy my criteria. But what we want to know is the sum of the perimeters. So let's see. So the perimeters are going to be the sum of the shorter length plus the longer length times 2. So maybe what I'll do is I'll sum up all those shorter and longer lengths, and at the end I'll multiply everything by 2. So for 50, you've got 15, and then for this 54, you've got 6 and 9 is also 15, and also this 8 and 7 is also 15, right? So that, and then the next two, these are going to be one bigger, right? 6 and 10 is 16. So if you see what I'm saying, these are all 15. And then these next ones, let's see, the next ones will be here. These will be 16. And then this last one will be 17. So you got 15 plus 15 plus 15 plus 16 plus 16 plus 17. So this is going to be 45 plus 32 plus 17. And that'll give me 4, carry the 1. Let's see, I got 9. And then I need to multiply this by 2 because the perimeter is not just the shorter side plus the longer side, it's double the shorter side and double the longer side. So 94 times 2 will give me 188. So that's my final answer on this one. Hopefully that made some sense. A little bit tricky. All right, let's go on to this one. This one says, this is number 23. It says an equilateral hexagon Okay, so what is an equilateral hexagon? It's not a regular hexagon, but it's equilateral. That means all these sides are all the same length. Okay? They're all the same length. And it says side length 5 meters. So all of the sides are actually 5 meters, right? We could write a 5 on all of these if we wanted to spend the time to do that. It has the property that ABDE is a rectangle. Okay, that's this thing here. ABDE is this middle part here. That's a rectangle. With BD is 6 meters. Okay, so this is 6 meters. And if it's a rectangle, well, this will be 6, and this is 5 because it's equilateral. Okay, what is the area of the hexagon ABCDEF? Okay, so to get the area of the hexagon, we need to take the area of the rectangle plus the area of these two triangles. These two triangles are identical, so if we can compute one of these triangles, the area, then we can just multiply by 2. So the area, let's do the area of the rectangle first, AR. So that's going to be 5 times 6, which is 30. Okay. Now let's do the triangle. So the triangle, I'm just going to redraw it here. It has a base of 6, and we don't know its height yet. We just know that the slant height, the diagonal distance up to the top, oops, is 5. So we don't know the height yet, but we can figure out the height because we know we can split the triangle in half. It's an isosceles triangle, so these two halves will be the same. And that means this is 3, and this is 3. And now we can see that we've got a right triangle here with hypotenuse of 5, and one of the legs is 3. That means the other leg is 4. So now we have the height of the triangle, and we do 6 times 4 divided by 2 to get the area. Base times height divided by 2. But there's 2 of these triangles, so maybe we just don't divide by 2. We just do 6 times 4. So the area of the triangle times 2, because we have 2 triangles, is going to be 24. And if we add the area of the rectangle times 2 times the area of the triangle, that's going to be 30 plus 24, and that's going to be 54. So the answer here is 54 meters squared. All right, let's go on to this next one. This one's 24. It says Ben chooses a perfect cube between 20 and 900, a perfect cube. He tells Adam the sum of the first and last digits of the cube. I should say digits, I think. He chose, and asks Adam to identify which cube it is. Adam correctly replies that he cannot be sure based on this information alone. What sum did Ben tell Adam? Okay. So it helps a lot if you know your cubes. We're going to have to go from 3 cubed all the way up to 9 cubed, because those are the cubes that fall within this range. So 3 cubed is going to be 27. That's the first cube that is bigger than 20. And then 4 cubed is going to be 64, 16 times 4. 5 cubed is going to be 125, because that's 25 times 5. 6 cubed is going to be 216. It's handy to just memorize the cubes up to at least 10. 7 cubed is 343. 8 cubed is 512. And 9 cubed is 729. Okay, so now what we're looking for is 2 cubes that have the same sum. So this is going to be the number here, this is going to be the number cubed, and this is going to be the first digit plus the last digit of the cube. Alright, so that's 2 plus 7 is 9, 6 plus 4 is 10, 1 plus 5 is 6. And what we're looking for is we're looking for 2 that are the same. Once we see 2 that are the same, we know that that's the sum we're looking for. 2 plus 6 is 8, 3 plus 3 is 6. Oh, okay, we can stop, because look, we've got 2 6's here. So now, might there be another duplicate if we keep going? There could be, but that would make this a bad problem, because you can, if there was, let's say there was another 8 down here, then there would be 6 and an 8, and there wouldn't be any way of knowing the answer to the problem, because all it tells us is that from the sum, he said that the other guy said that he couldn't tell which one it was, and it asks you what the sum is. So I'll go ahead and do them and show that that's not the case. We got 5 and 2 is 7, and 7 and 9 is 16. So yeah, the only one that pairs up is 6. So our answer is going to be 6. And yeah, if one of these had been 8 or something, then this would have been a bad problem, because there wouldn't have been any way to tell the sum that was told based on the information given. All right, so the answer is 6. Let's go ahead and move on to this one. This is problem 25. It says, what is the least positive integer x for which the quantity, and they give you this ratio here, is at least 80%? Okay, so we can just write that down. We just write down 20 plus x divided by 26 plus x is greater than or equal to, right? Because, let's see, the least positive integer for which the quantity is at least 80%. So that means it's greater than or equal to 0.8. 0.8 is the decimal way of writing 80%, because 80% is 80 over 100, per 100. Percent means per 100. So 80 divided by 100 is 0.8. All right, so let's multiply both sides by this denominator so that we can get rid of it. So then that gives us 20 plus x is greater than or equal to, well, let's see. Actually, yeah, I think I'm going to write this 0.8 as 4/5. And then I'm going to multiply everything by 5 also, just so that I can get rid of this denominator at the same time. So I'm multiplying by 5 times 26 plus x. I'm multiplying both sides by that. So let me start over when it comes to this part down here. All right. So I'm going to have 5 times 20 plus x, and then this part cancels out, is greater than or equal to 4 times 26 plus x. Because I multiplied by 5, that got rid of this, and then I multiplied by 26 plus x, so that put this here. So now I've got 100 plus 5x is greater than or equal to, let's see, 26 times 4, that'll be 104, right? Because 25 times 4 would be 100, so this should be 104 plus 4x. And now I'm going to subtract 100, and at the same time I'm going to subtract 4x from both sides. That should make things nice and simple. So this gives me x is greater than or equal to 4, yeah, just 4. X is greater than or equal to 4. So the least positive integer is going to be 4. So the answer here is 4. If x is greater than or equal to 4, the equation is satisfied. So the lowest number, which makes this true, is 4. All right, we only have 5 more sprint problems to go. This is problem 26. This says at Sugarloop Donuts, 1 sprinkle donut costs $1.32. Liam has an ample supply of 1 cent, 10 cent, and 50 cent coins. In how many different combinations of these coins can he pay for 1 sprinkle donut with exact change? So whenever you have a problem like this, it's basically a matter of separating it up into cases. So I like to start with the biggest coin first. You can take different options for how many 50-cent pieces he has. So let's do 50-cent pieces. How many 50-cent pieces is he going to use? How many 10-cent pieces is he going to use? And how many 1-cent pieces is he going to use? We can make like a table like this, right? And find all the combinations that add up to $1.32. So let's start with the most 50-cent pieces that he can use. So that's going to be 2. Because if he uses 3, that'll already be $1.50. So 2 50-cent pieces, and then let's also use the most 10-cent pieces that he could use. So that'll be 3. And then for the 1-cent pieces, once I pick these two, this number is going to be something. You don't have to figure out what it is. It's going to be something. There's only going to be one option. So I'm not even going to write down that number. I'm just going to say, yeah, there's some number of pennies that will make these 2 50-cent pieces plus these 3 dimes get up to $1.32. In this case, x is 2, but I'm not going to even bother to compute that. When I do the next case will be 2 and 2, right? And in that case, there will be some number of pennies. It'll be 12, but I don't even care about that. It's just some number. And then 2 and 1, and 2 and 0, basically. So there are 4 possibilities here. That's all the possibilities where you have 2 50-cent pieces. The number of dimes can be 3, 2, 1, or 0. And then whatever you need to, in terms of pennies, to get up to the $1.32. So that's all the cases where you use 2 50-cent pieces. Now, what happens if you only use 1 50-cent piece? Well, if you only use 1 50-cent piece, you could use 8 10-cent pieces, or 7, or 6, or 5, or 4. So it's going to be basically 8, 7, 6, all the way down to 0, right? So it's kind of the same thing we did here, except we've got 5 more possibilities because we got rid of a 50-cent piece. So that gives us 5 more dime possibilities. So the total number of these is going to be 4 plus 5, which is 9. And then we've got one more case, which is, I'm running out of room here, but one more case where you have 0 50-cent pieces. And there's going to be an additional 5 options there. So you're going to have, in total, you're going to have 4 where you have 2 50-cent pieces. You're going to have 9 possibilities where you have 1 50-cent piece. And then you're going to have 14 where you have 0, right? That'll be anywhere from 0 up to 13 dimes. So we just need to add up these numbers. Let's see. So that'll be 27, right? We'll have 27 different combinations of ways to pay for that sprinkle donut at Sugarloaf Donuts. Okay, so our answer is 27. All right, let's go on to the next one, problem 27. This one says if parallelogram ABCD has AB 10 units, okay, that's shown here, and BC is 14 units, and the measure of angle ABC is 60 degrees. Okay, they've got all that information on this figure. What is its area? Okay, so we want to know what the area is. What is the area? And it says express your answer in simplest radical form. So for the area of a parallelogram, it's very similar to the area of a rectangle. It's just the base times the height. All right, that's the same formula as a rectangle. A rectangle is just one particular special kind of parallelogram, and actually you can see that. They're the same. Like, for example, let's say you chop off this triangle. You just chop this triangle off. You can paste that triangle over here, and you'll get a rectangle with the same area. If you take this part off and you stick it over here, you just move it and stick it over there, you'll get a rectangle with the same height and the same base. So obviously the area hasn't changed when you did that moving around. So that means the formula for the area of a parallelogram is the same as the formula for the rectangle. Now the only problem is we don't have the height yet. We need to find the height. And how are we going to do that? Well, we know this diagonal distance is 10, and we know that that this base here is 14. So what do we do next? Well, fortunately, this is a 60-degree angle. And so we have what's called a 30, 60, 90 triangle here. So you've got, because the height always forms a right angle with the base, that means we've got a triangle here that's a right triangle. And when you have a right triangle, the shorter leg, a 30, 60, 90 triangle, the ratio of the sides of that triangle is 1, 2, square, oh sorry, I wrote that wrong. 1, 2, square root of 3. Okay, so if we scale that up to this triangle where this is 10, we have to scale everything up by 5. So that means this will be 5 root 3, and this will be 5. So yeah, the important thing is this one, because this is the height. So we've got 5 root 3 is the height. So now we can compute our area. The base is 14, and the height is 5 times the square root of 3. And so 14 times 5 is 70, so we have 70 times the square root of 3. And that's our area. That's what they wanted, 70 times the square root of 3. And they said express your answer in simplest radical form. That kind of gives you a little bit of a hint that you're going to need a square root or something like that. And so you can feel good about your answer because that's in the simplest radical form there. Okay, let's go on to the next one. So this is problem 28. We're getting into the really hard ones. Actually, the last few have been pretty hard too. This one says a gym teacher wants to divide a class of 12 students into 2 teams of 6 to play volleyball. If Elijah and Ryan must be on the same team, in how many ways can the 2 teams be formed? So I think this is a tricky one. You know, you might not think about this the right way if you're, you know, in a hurry, and there's lots of different ways to think about this. You might start figuring out how many ways. You know, you might say that there's team A and team B, and you might think, okay, well, how many ways can I form team A, and then how many ways can I form team B? The problem is that there isn't a team A and a team B. There's just 2 teams, and so if you form the 2 teams, let's say you put Elijah and Ryan on this team, and you pick 4 other students to go with them, and then you pick 6 students over here. This is the same as if you switched it so that this was team B and this was team A. That doesn't count as a separate thing. So I think the best way to think about this problem is first, well, the best way to think of it is, okay, let's put Elijah and Ryan on the same team. Doesn't matter whether it's team A or team B. Let's put them on the same team, and then let's pick the 4 students to go with them. How many different ways can you pick those 4 students? There's 10 students left. Once you put Elijah and Ryan on the one team, there's 10 students left, and you need to pick 4 to go with them. So basically that's 10 choose 4. So you can write it like this, 10 choose 4. And if you write it out with this is going to be 10 factorial divided by 4 factorial, 6 factorial. So that'll be 10 times 9 times 8 times 7. And I'm not going to write the 6 all the way down to 1 because that's going to cancel with the 6 factorial. And then I'm going to divide that by 4 factorial, 4 times 3 times 2 times 1. And of course 4 and 2 cancel with the 8. And 3 and 9, that gives you just 3 up here. So you've got 21 times 10. That's going to be 210. So that is our answer to this one, 210 ways. It's just 4 choose 10. All right, let's go on to problem 29. This one says, Anne, Sasha, and Marcy each roll a fair standard 6-sided die. What is the probability that the number showing on Anne's die is strictly greater than the numbers showing on both Sasha's and Marcy's dice? Express your answer as a common fraction. Okay, so this is a tricky one. I think this is a pretty tricky one. But what I like to think about is let's separate out Anne from Sasha and Marcy. So Anne's die, there are 6 possibilities, right? Anne could be 1 or 2 or 3 or 4 or 5 or 6. This is Anne. And let's think about, for each of these probabilities, for each of these cases, they're each equally likely. Let's think about Anne rolling her die first. And let's think about each of these cases and think about what's the probability that Sasha and Marcy's dice are going to be smaller than Anne's. So let's say Anne rolled a 1. What's the probability that both Sasha and Marcy will roll something lower than 1? That's 0, right? Because it's impossible for Sasha and Marcy to roll lower than 1 because 1 is the lowest number. Okay, let's go on to number 2. So for number 2, what is the probability? If Anne rolls a 2, what's the probability that both Sasha and Marcy are going to roll lower than a 2? That means they both have to roll a 1, right? So I like to think about, when I think about rolling 2 dice, I like to think about this sort of a 6x6 grid. Like, you know, there's you can think about dots like this. Obviously you don't want to be drawing this out because it would take forever, but you can think of a grid, oh, it's a little messy. You can think of a grid like this of all the possibilities when you roll 2 dice, and there are 36 possibilities altogether, because this is like a 6x6 square, right? So this dot here represents a 1 and a 1, right? And this dot way up on the other side represents a 6 and a 6. So that you might think of this as this dimension is Sasha's roll, and this dimension is Marcy's roll, right? So you can roll a 1 and a 1. That's the only possibility that is going to have them both lower than 2. Right? So this is basically a 1 in 36 chance. There's 36 possibilities, and only one of them is going to satisfy our criteria where both Sasha and Marcy's die is lower than 2. Now if Anne gets a 3, you have more possibilities. Instead of just this one, you have 4 possibilities, right? All 4 of these. This is 1 1 1 or 1 1 1 2 2 1 and 2 2. In all 4 of those cases, you're going to be below 3. So that's going to be 4 out of 36. And then in the next case, you're going to have 9 possibilities. So if Anne rolls a 4, there are 9 ways out of 36 that Sasha and Marcy's rolls are going to be lower than Anne's roll. And then you can just keep going like that, right? So the next one is going to be 16 ways out of 36, right? This is 16 ways out of 36. And then the last one is going to be 25. So if Anne rolls a 6, there are going to be 25 out of 36 ways for Marcy and Sasha to both roll less than 6, right? If you're anywhere up on the top row or the rightmost column, that means one of them at least got a 6. So basically we just have to take the average of all these probabilities because all these possibilities are equally likely, right? It's equally likely that Anne will get a 1, a 2, a 3, a 4, a 5, or a 6. So in those cases, these are the probabilities, and if we wanted the probability of this whole thing happening, we just have to take the average of these 6 probabilities. So we can add these all up and divide by 6. If we add them all up, we get 55 over 36, but we still have to divide by 6, and so our final answer is, so we're going to multiply this by 1/6, and that's going to be 55 over 216. And so that's our answer here. Oops. 55 divided by 216. And they said express your answer as a common fraction. One thing I realized I maybe have never taught you guys, but a common fraction is it's got an integer on the numerator and an integer on the denominator, and it's simplified so that these two numbers are relatively prime. In other words, they don't have any common factors. So for example, 8 over 12 would not be a common fraction. You'd have to divide both top and bottom by 4 to get 3/4. That would be a common fraction. And then like 11 over 7 would be a common fraction, for example. You wouldn't rewrite this, if they asked for it as a common fraction, you wouldn't rewrite this as a mixed number like 1 and 4/7 or something like that. Mathcounts never wants the mixed number. They always just want you to write it as a fraction, an integer over another integer. All right, let's go on to number 30. This one you kind of had to read the problem carefully. It says Stacy is jogging a park that has 2 rivers. From the entrance, okay, the entrance is labeled here. From the entrance, she first follows the Ruby River path, which runs 2 miles due west. Okay, west is in this direction, so this is 2 miles. And then 2.5 miles in a straight line along the river. Okay, you've got the river drawn in here. She turns, she goes 2.5 miles along the river. That's 2.5 miles. It says at the end of this path there is a shortcut due south to the park entrance. That's this dashed line here. It says, but instead, Stacy takes the Sapphire Stream path. This path runs 3.6 miles due east. Okay, so let's do this other path in another color. 3.6 miles due east. That's this one here, 3.6. And then it says, and then follows the stream in a straight line back to the park entrance. Okay, straight line back here, but it doesn't tell us how far that is. So this is question mark. What is the total distance that Stacy jogs? Okay, well, that is the real question here is how far did she jog on that last leg? Because everything else is easy. We can just add 2, 2.5, and 3.6. So what would that give us? 4.5 plus 3.6. That would be 8.1. So it's 8.1 plus x, whatever this x is here. Okay, so how are we going to figure out this distance? Well, maybe we can figure out this distance here. And that's not too bad because this is basically a 3, 4, 5 right triangle. The reason we know it's a right triangle is because it says there's a shortcut due south. So this is perfectly south, and this was perfectly west, so we know that those are at a 90-degree angle. So 2 and 2.5, if you multiply those by 2, you get 5 and 4. So this is in the ratio of a 3, 4, 5 triangle. That makes this the 3 leg, but you have to divide by 2. So that means this is 1.5. This height here, this is 1.5. Now, you could just use the Pythagorean theorem and do this squared plus this squared and take the square root to get this. But if you're, and you could have done the same thing here too. You could have done this squared minus this squared to get, and taken the square root to get this distance, right? But recognizing that 3, 4, 5 triangle saves you a little bit of time because, you know, doing 2.5 squared, that's a little bit of a pain, right? It's like 6.25 is 2.5 squared, and then you have to subtract 4. That gives you 2.25, and then you have to take the square root of this, and the square root of that is 1.5, but, you know, it's kind of a little awkward to do the square root of this. So especially without a calculator. You might recognize it as 225, and you know that's 15 squared, but yeah, it's a little awkward. So hopefully you recognize that these are in the ratio of 3, 4, 5 triangle here. And the same thing is true of this one too. This is in the ratio of a 5, 12, 13 triangle. So 5, 12, 13, which is like the second most famous Pythagorean triple. So in math counts, it's useful to know the 3, 4, 5 Pythagorean triple and the 5, 12, 13. And there are a few others that are useful to know as well. But this is in the ratio of 5, 12, because if you multiply this 5 times 0.3, you get 1.5. And if you multiply 12 times 0.3, you get 3.6. So that means x is just going to be 13 times 0.3, 0.3. And 13 times 0.3 is 3.9. And so now we can plug that in here. 8.1 plus 3.9 will give us our total distance that she jogged. And that is going to be 12. Sorry, 12. 8.1 plus 3.9. It's like 8 plus 4 if you take the 0.1 over here. So that's 12. 12 miles. Okay, that's the end of the sprint. Let's go ahead and move on to the target. So problems 1, 2, and 3, we had more than half of you guys get those correct. So let's go ahead and look at problem 4. This was the hardest of all the problems in the test. So it was harder than any of the sprint problems, harder than any of the other target problems. Nobody got this one right. So you don't have to feel bad about missing this one, but I do want to show you how to do it. It's not super hard, but it does take quite a bit of time. So you have to have finished problem 3 really quickly, and then you have to work really fast on this one to get it done within the time limit because it really is a hard problem. So it says Cecilia read consecutive pages of a 60-page comic book, and the sum of the page numbers she read was 300. What is the sum of all possible values for the page number of the final page that she read? Okay, so she read consecutive pages, and the sum of all those pages was 300. So when you read consecutive pages, if you want to sum up those page numbers, basically you're summing an arithmetic series, and whenever you sum up an arithmetic series, not any arithmetic series, whenever you're summing consecutive integers at least, the sum is going to be equal to the starting integer plus the ending integer times the number of integers divided by 2. Okay? And the reason is, well, let's say you have some integers. here that you're adding up. They're consecutive, right? So this is the starting one, and this is the ending one. The average of all those integers is going to be somewhere in the middle here. The value of the average of all these integers is going to be s plus e divided by 2, right? And then the total number of integers is going to be n. N is just the number of numbers you have. So multiplying this by n. If you multiply the average times the number of numbers, you're going to get the sum. And also we can write down that the ending number is equal to the starting number plus n minus 1. And that might be useful to us at some point as well. Okay, so let's see what we can do here. So this sum, or sorry, this is the sum of all those consecutive page numbers. That's going to equal 300. Okay, so if it can be useful to multiply this whole thing by 2, because then you get rid of this denominator here. So then you have s plus e times n is equal to 600. So now we're getting somewhere because we've got two integers that multiply to give us 600. And there's a lot of possibilities because 600 has a lot of factors. But we can maybe throw out some of those possibilities. So let's start by writing down different possibilities for n. Okay, and then once we know n, 600 divided by n will be the starting number plus the ending number. All right, so this is going to be 600 divided by n. And then once we know that, we can figure out the ending number based on this formula here and this formula here. So basically, how do we do that? So say you want to know what say you want to know what s plus e is. Well, s plus e, if we plug this in for e, that's going to be s plus e is going to be e plus e minus n minus 1. Okay, because this is equal to s. S is going to be the ending number minus the number of numbers minus 1. So if we know s plus e and we want to know e, we just need to take s plus e and then add n minus 1. Okay, and that'll be 2e, and then we'll divide by 2, and that will be e. Okay, so let's put e here. So there's a bunch of possibilities for n. One thing you might try to do is say, well, what's the lowest possible number that n could be? So for example, let me think. What's the lowest possible number? Well, or what's the highest possible number that n could be? Like let's say you tried to start at page 1, right? And you read page 1 plus 2 plus 3 all the way up to n, and you wanted that to be 300. That would give you the most pages you could possibly read. If you start at page 1, that would be the most pages. So that would be the biggest possible number for n. So maybe we can figure that out, and then we can use lower numbers for n and see what happens. So what is that? So this is going to be, so 1 plus 2 plus 3 all the way up to n, that's going to be equal to n times n minus 1 over 2, which is equal to 300. And that means that n times n minus 1 is going to be equal to 600. And if you plug in some numbers here, you'll find out that n is 24. 24, because 24, well, you can think about, this is approximately equal to n squared, and it's a little bit less than n squared is 600. So if you know your squares, if you have your squares memorized up to 23 or so, yeah, let's see, you got 23 squared is 529, or no, 24 squared is 576 plus 24 is 600. So that means n, did I do this right? N, no, I'm sorry, this is n times n plus 1 over 2. Sorry about that, my bad. Okay, n times n plus 1 equals 600. So yeah, 24 squared, so this is n squared plus n squared plus n. And that gives you 24. So 24 is the highest possible value for n. And if you do 600 divided by n, it's useful to do the prime factorization of 600. So that's going to be 5 squared times 3 times 2 cubed, I believe. So that'll be 8 times 3 is 24, and 24 times 25. So that'll make this 25. And from this equation, we can take our s plus e, add n minus 1, which is 23. So 25 plus 23 is going to be 48, and then divide by 2, the ending number is 24. And that makes sense because we went 1 to 24, right? So we have those page numbers. So that's one possibility, is that the ending number is going to be 24. And then we got to consider all the numbers of pages less than 24. And basically, we can think they have to be factors of 600. So we can take, different combinations of multiplying these prime factors. Well, let's just take from 24. 24 is 2 cubed times, it's 2 cubed times 3, right? 2 cubed times 3. So that's all this part here. And then if we want to make something less than 24, we can start taking away some of these prime factors, or we can add in the 5. So let's just take away the 2, that gets us down to 12. We could take another 2 out, that'll give us down to 6. We could take another 2 out, that'll get us down to 3. So that all leaves the 3 in, but another way to do it is to take the 3 out, that gets us down to 8, and then we got 4 and 2 if we take out some 2's from there. So what do we get for 600 divided by n in these cases? So if we're dividing by 2 here, we have to multiply by 2 here. That gets us to 50. And so what's going to happen here? Let's take our 50, that's s plus e, we're going to add n minus 1. So we're going to add 11, that gets us to 61, and then we divide by 2 to get the ending number. That's going to be not an integer, right? So what happens is, you might notice a pattern here. When both of these numbers are even, it's not going to work out, because you're taking an even number, you're adding the other even number minus 1, that's going to give you an odd number, and then you're dividing by 2. So when these two are both even, things are bad. And that's going to happen that's going to cancel out this case. It's also going to cancel out this case and this case, because these are all just going to be multiplying by 2 again and again. So basically you need all these 2 factors to be on the same side. So we can go down to 8. 8's another possibility. In order to get from 24 to 8, we divided by 3, so that means this one has to multiply by 3, so that'll give us 75 here. And then you take the 75, you add 7, because that's this minus 1, that gets you up to 82, and you divide by 2, you get to 41. So the last page would be 41 in that case. And then in this case, you're up to 150 here. And this is not going to work, because if starting number plus ending number is this big, it's not going to work for a 60-page comic book, right? The biggest you can have for the starting and the ending page is 60 plus 60, which is 120. So we can automatically cancel this one out and cancel this one out. So now we've got two possibilities, but we haven't done everything yet. We also have to consider the case where you multiply by 5 over here. So we know we don't want to have, we know we want to have either, yeah, we want all the 2 factors to be either here or here. So 8 times 5, let me make some room down here. Let's see, we'll cancel out some of these ones that we already eliminated here. I'm going to get rid of these ones too, just to make more room. Oh, okay. All right. So 8 times 5 would be 40. So we multiply by 5 here, we have to divide by 5 here. That'll get us to 15. So the problem is this is way too low. If you've got, well, actually 40 pages is already too high. We know 24 was the biggest one, so that's not going to work. We're going to have to, so that means we can't have the 8 and the 5 both on this side. So that means we need to just have the 5 here, we'll have the 8 on the other side. So if we have 600 divided by 5, that gives us, what is it, 120? So 120 plus 4 is 124. Divided by, yeah, that's going to be too big. That's going to give us 62 or something, so that's too big. So then you can multiply, you can make 5 bigger, but you can't multiply by 2 because all the 2's have to be on the other side. So we can do 5 times 3 is 15. That's multiplied by 3 here, divided by 3 here, that's 60. And you take 60 plus 14 is 74, divided by 2 is 37. What am I doing wrong? Let's see. Yeah, 27, right? We did, I did that wrong. We had, oh no, 15 was supposed to be 40 here. Oops. This was 40. Yeah, because multiply by 3, divide by 3, that's 40. 40 plus 14 is 54, divided by 2 is 27. Yeah. So those are all the different possibilities, and yeah, that takes a long time to figure that out. It's really hard to do that in 6 minutes. But if you add these up, and maybe there's a quicker way that I missed, but in any case, you add that up, you get 80 plus 12, so that's 92. 92. I'm gonna have to think about that and see if I can come up with a faster way. But there's a couple tricks there. You know, you got to find the limit. You know, find the highest value of n, and then get rid of all the ones that are both even, and go through all the possibilities. But yeah, that one takes a long time. Okay, let's go on to the next one. This one says a square is inscribed in a circle of radius 8 units. The square divides the interior of the circle into 5 regions, 4 of which lie outside the square. What is the area of the shaded region? Express your answer as a decimal to nearest tenth. So as in a lot of geometry problems, the most important thing is to find the right thing to add in. So in this case, adding in some lines that go diagonally. Oops. Let me see. See if I can do this right. Adding in these diagonal lines, cutting the circle into 4 regions is a useful thing. Just basically slicing the pizza, because now we can just focus on this one pizza slice, right? So there's this one pizza slice up here, which is a quarter of the circle. And we can take that quarter circle, find its area, and then subtract the area of this triangle, and that'll give us this shaded area. Okay, So let's find the area of the quarter circle. Area of the quarter circle is going to be 1/4 of the area of the circle. The area of the circle is pi r squared. So do we have the radius? Yeah, it says the radius is 8. Okay, so this is going to be 1/4 of pi times 64. So 64 divided by 4 is going to be 16 pi. So 64 divided by 4 is 16, and then pi. So that's the area of the quarter circle. Now we need to subtract the area of the triangle. So the triangle is, it's a triangle with 8 as its base and 8 as its height. So the area of the triangle is going to be 1/2 the base times the height, right? Base times height over 2, which is 64 divided by 2, which is 32. And then all that remains is to subtract these two numbers, right? So we have 16 pi minus 32. That should be our answer, but they want it as a decimal to the nearest tenth. So that's where a calculator comes in. And yeah, you're allowed to use a calculator because this is the target problem. So we do 16 times pi, you can approximate as 3.14159 or whatever, however much you want to go. You only need to answer as a decimal to the nearest tenth, so you don't need to put a whole lot of digits of pi like this. But yeah, that gives us 18.26 blah blah blah. And we're going to round that to the nearest tenth. It's going to be 18.3. All right, so our answer is 18.3 on this one. All right, and we've got 2 more problems. So problem 6 here, this was a pretty tricky one. This says Ethan draws 4 cards from a standard 52 card deck without replacement. What is the probability that no 2 of them will be the same rank or the same suit? Okay, rank means like the number or the face, right? So the ranks are 1, 2, 3. I guess the 1 is an ace, right? Ace, 2, 3, 4, 5, all the way up to 10, and then you've got Jack, Queen, King, right? So those are all the ranks, and then the suits, you've got spades and diamonds and let's see, clubs and hearts, right? So there's 4 different suits and there's 13 different ranks, and when you multiply by 4 by 13, you get your 52 cards in your standard deck. All right. So what's going to happen when he picks one card? It might be like, let's say it's a 5 of diamonds or something like that. That is going to be this card here, and that is going to kind of eliminate all the other 5s and all the other diamonds from being cards that can be picked in the future. In order to keep his thing going where he has no 2 the same rank and no 2 the same suit. So it's a little hard to visualize if I pick one in the middle like this, because now I have these 4 different rectangles that are left over and I want to figure out how many are left over. So what I'm going to do is, instead of that, I'm just going to say, okay, let's assume, since I can pick whatever I want, let's assume that he actually picks the ace of spades, this very first card here. And then that's going to eliminate this one, this one, this one, and it's also going to eliminate all of these guys across here, right, all the way down to the king. So he picks this card. It doesn't eliminate them from the deck. It just makes them cards that he can't pick in order to keep avoiding duplicates, right? And then I'm going to say, okay, let's say that the next one that he picks is the 2 of diamonds. All right, so he's going to pick this one, 2 of diamonds, and then that's going to eliminate all these, and it's going to eliminate all these. And then I'm going to say that the next one he picks is the 3 of clubs, right? And that's going to eliminate these and eliminate this. And then I'm going to say that the next one that he picks is the 4 of hearts. So that's just how I'm going to think about this. All right, so what is the probability that this is going to happen? And it's not the probability he's going to draw these exact ones, but the probability. But I'm picking these ones just so that I can compute the probability. So okay, so the first card he draws, there's no way he's going to break his criteria of having two the same because he's only got one so far. So there's a probability of 1 that after one draw, things are not broken. Does that make sense? And then, but once he picks that one, now it says without replacement. So the next one, so now there's going to be 51 cards left, right? So the next one is going to be something over 51. And what is it going to be? It's going to be, there's 3 suits left that he can pick, and there's 12 ranks left that he can pick. So it's 36 over 51 is going to be the probability that he doesn't have any duplicates after his second draw. And then for his third draw, there's only going to be 2 suits left, and there's going to be 11 ranks. So that's going to be 22 over 50, because there's only 50 cards left now that he's taken these 2 cards out. And then once he's picked those 3, there's only 1 suit left that he can pick, and there's 10 ranks left that he can pick. So basically you've got these, I'm computing these areas of these different rectangles, right? So the first rectangle is, 52 out of 52, right? And then the second rectangle is going to be this one, which is 36 out of 51. And then the third rectangle is going to be this 22 out of 50. Oops, I used the same color. And then the last one is this rectangle here, which is it's 10 over 49. So now we just need to multiply this all together. 36 times 22 times 10. I guess I can start canceling some things too, because this is an even number. So that'll get to 5, and this will get to 25, and I can cancel the 25 and the 5. I should have just canceled those to make 5. Okay, so that's 5. And let's see, 51 is divisible by 3, right? So what is that going to be? We've got 17 and 12. Okay, now everything's odd on the bottom, and I've got 12 and 22. Is there a factor of 3? No, this is 7. These are all primes, basically, so yeah, I think that's as good as I can do. So now I've got 12 times 22, and since I've got a calculator on this one, I can just do it like this. 12 times 22, it's going to be 264. So this is 264 on the top. And then on the bottom, I've got 17 times 5 times 49. 17 times 5 times 49. That gives me 4165. 4165. So that's my final answer. 264 divided by 4165. All right, we only have one problem left. I should say, before I go into this one was also very hard. Nobody got this one right. Although I don't think it was as hard as problem 4. This one was the hardest one, but this was the second hardest problem, I would say. And yeah, nobody got this one right, but I think it's reasonable. I think someone could have gotten it. Then there's this one. I think only 2 people got this one right. But it's not too bad. So let's take a look at this one. So it says rectangle math, M-A-T-H, shown below, has AM is 8, AP is 5, that's this diagonal distance here. AT is 15, and what is the area of PTH? Okay, so they want to know the area of this triangle here. What is the area of that thing? Okay, so the best way to figure out this area is going to be to find this base here from T to H. And actually we already know that since it's a rectangle, that's going to be 8. So the area is going to be 8 times the height, right? If we find that height there, we'll be done. All right, so this problem is going to test whether you know your Pythagorean triples, I guess, because this distance from A to H is 17. Okay, so AH is 17. And the way you know that is if you have your Pythagorean triple 8, 15, 17 memorized. But if you don't have that memorized, you can just use the Pythagorean theorem, right? So that's 8 squared is 64, 15 squared is 225. You can add those together, and you get 289, and the square root of 289 is, square root of 289 is 17. All right, so that gives you this distance from A to H. Now, I want to point out that you've got two triangles here. One of them is this PTH, and another one is ATH. ATH. And those two triangles have the same exact base. They're both 8, but they have different heights, right? So triangle ATH area, let's say the area here, is going to be 8 times 15, it's a 1, 15 divided by 2, right? Because that's base times height divided by 2. And then the area for triangle PTH is going to be 8 times its height divided by 2. So what is this height here? Well, one way we can figure it out is this. There's a similar triangle. There's a similar triangle here. Let me draw that in a different color. So there's this triangle ATH is similar to this triangle here, where I drop this height down. It's perpendicular here. So those are similar triangles, and so I can compute this height H. H is equal to 15 times 12 over 17. Right? So that basically it means the height of this triangle here is 12/17 the height of this triangle. And so that means the area of this triangle is also going to be 12/17 the area of this triangle. So basically this is going to be 8 times 15 over 2 times 12 over 17. Because these hypotenuses of these triangles are 12 and 17, right? This is 12, and this is 5 plus 12, which is 17. So yeah, that's my answer. I just need to simplify it. Let's see, this can cancel to give me 6. And then I have 6 times 15 times 8. That's going to be 48 times 15. I guess since I have a calculator, I'll just use that. 48 times 15. Oops. Times 15. 720. So 720 over 17. 720 divided by 17. Okay. Hope you guys enjoyed that. Hope you guys learned some useful things there. And I will see you guys in the next video.